Parallel and unit vectors, or parallelism and unit vectors, combining both these. We're not going to spend a lot of time on parallelism because it's pretty simple. If it is a scalar, if a vector has a scalar, if they have a common multiplier, if I notice that they have a common multiplier and one's a scalar, it doesn't have to be a whole number, it can be a fraction, can be negative, could be whatever it is. As long as they have a common scalar, if k times b is equal to a, if some number times b is equal to a, then a and b are parallel. Okay, it doesn't have to be an example. So by example here, let's just take this for example down here at the bottom. Are a and b parallel? Yes, because I can see that 2 times 3 is 6, 2 times 5 is 10. They're parallel. One just happens to be twice as long. It's traveling in the same direction. Rise over run is the same. Okay, so it's rise, the slope or the direction they are actually traveling is rise over run. In this case, 5 over 3. In this case, 10 over 6, which both equal the same thing. Okay, so rise over run. So let's just take this for example. Find R and S if A equals that vector and B is parallel to B and it equals that one. So what we know is that 2, -1 times R times some factor, some K, is equal to S2 and -3. So we can really write equations. 2k equals s. Well, I have two variables there. -1k equals 2. Only one variable there, so I can find k. And then r times k equals -3. So I'm going to solve this one because I can actually see, as I've only got one unknown, I can find out what k is. So k is -2. Once I know that k is -2, I can find r and s. So if I put -2 in here, 2 times -2 equals s, so s is -4, and down here on this bottom equation, I've already solved this one, now I've solved that one, and down here on the bottom, it's going to be r times -2 equals -3 divided by -2, so r is -3 over -2, which is 1.5. So we can find both of those based on the fact that we knew that they were parallel. Okay, what would make them go parallel in the opposite direction? Just k would have to be a negative, like in this problem. These are going in opposite directions. All right, so continuing on. So parallel. What would make it twice as long? Well, k would have to be 2, and so on. All right, so here we go. Now, this is part where students usually get confused is unit vectors. There's two types of, or two ways we talk about unit vectors. A unit vector is any vector that has a length of 1 unit, okay? That has a length of 1 unit. So the vector 2, 3 has a length of 2 squared plus 3 squared, or the square root of that, square root of 13. It's not a unit vector, okay? Because it doesn't have a length of 1. We want it to have a magnitude of 1. So here's an example, 1, 0. Has a magnitude of 1 or a length of 1. And that's what we're going to find. That's one type of unit vector. Now that's the unit vector, just a unit vector. We also have unit vector form. And unit vector form we see are vectors that show up in composite form when we use I, J, and with 3 dimensions we'll use K. I represents the x, the horizontal movement. J represents the vertical movement when it's 2 dimensions, or I, J, and K. Okay, so I is the x movement, J is the y movement, K is the z movement, respectively, for those. So here's a vector, 3-dimensional vector. This can be rewritten as 2I plus 3J minus 1K. This is unit vector form. Completely different than a unit vector. A unit vector is 1 unit in length. A unit vector is 1 unit in length, whereas this has a unit vector form where we use I and J. So same thing, we can still find the unit vector, finding its length of 1. We can still do all those other things. We can find the magnitude, we can find the direction. Eventually we'll be able to find angles using the dot product and so on. So this is all, nothing changes to different form as opposed to composite form or component form. Component form, this is unit vector form. Sorry, it's already written over there. Continuing on. So component form versus unit vector form summarized here. V1, V2, V3 is V1 times I, V2 times J, V3 times K, and so on. Can be 2 dimensions or 3 dimensions. Doesn't really matter which direction we write it. You'll just see them written. You actually see them written this way a lot because you don't have to do any special typing. You can just write them in, type them into problems. And you're going to see that on the exams as well. All right, so here, find the length of vector 2i minus 5j. Find the length of the vector. All you're going to do is find the magnitude, the length of it. So I take each part. I'm going to take 2i, the vector, the magnitude of 2i plus 5j, 2 squared plus negative 5 squared, square them, add them, square root them, and I get square root of 29. That's all there is to that. Now here it's asking for a unit vector. So we need to find the value of k that has a length of 1. So really what we want to know is this vector, negative 1/3 k, has to have a length of 1. Well, to do that, I'm going to simply take negative 1/3 squared plus k squared. I'm going to square root that equals 1. Because that's how you find magnitude, is to square them, add them, and square root them. So to get rid of the square root, because I've got to solve for k, I square both sides. The square and squared cancel out. So now I have negative 1/3 squared plus k squared equals 1. Well, negative 1/3 squared is 1/9 plus k squared equals 1. So subtract 1/9 from both sides. So k squared equals 8/9 when I subtract 1/9 from both sides. And now I square root that. So k is the square root of 8 over 3. Or 2 square roots of 2 over 3 if you want to rewrite it in radical form. You could go the square root of 8/9, which is all the same thing. Okay. Continuing. Unit vector properties. So unit vector properties, a unit vector. Now this is again talking about the unit vector length of 1, not unit vector form. Okay, unit vector properties. We can convert or find a unit vector for any vector. We can find it and convert it to a length of 1 simply by taking 1 over the magnitude of the vector times the actual vector. So 1 over the vector times the vector gives us a unit vector. If I want it to go in the same direction, k is 1. Okay, but if I want it to be the length of k, I put k on top over the length times a. If I want it to go the opposite direction, I'm going to just have negative k. Okay, anything that's parallel is going to be positive or negative. 1, 5, 10, k, whatever it is, over the length of the vector times the vector. So here's the situation. Let's just say I want this, I want to find a unit vector for this. First thing I'm going to do is find the magnitude of the vector. What's the magnitude of this? Square root of 13. So I put 1 over the square root of 13. Multiply it. Now I've found the unit vector. That's the unit vector. It has a length of 1, and if I wanted to confirm that, I would simply do all of this work. Okay? Square them, add them, square root them, and I see that it has a length of 1. Okay? But all you do is find the magnitude of the vector, find the magnitude of the vector, which is 13, put it 1 over 13, times the vector itself to get my unit vector. Continuing, so here we want to find a vector b, so we want to find a new vector, b, that has a length of 7 units in the opposite direction of vector a. So we know it has to be 7 units long, but it has to be in the opposite direction. So we're still going to use 2, negative 1, 1. It has to be a length of 7 in the opposite direction. So opposite direction is going to be negative. It has to be a length of 7 over, now what I'm going to do here is I'm going to find the magnitude of this vector. So that's 4, 5, 6. The square root of 6 goes on the bottom. So this is going in the opposite direction because of the negative. I'm multiplying by 1 over the square root of 6. That's going to give me a length of 1, but if I take that length of 1 times 7, I wind up with a length of 7. So this is simply going to be negative 14 over the square root of 6 and 7 over the square root of 6 and negative 7 over the square root of 6. That's my new vector. It is 7 units long. It's going in the opposite direction of A, and it's parallel. Okay, that's all you would need to do there. The 7 tells me the length. The square root of 6 converts it to a unit vector, which would, by putting 1 over that, converts it to the unit vector of 1, and the negative makes it go in the opposite direction. And that's all.